Continuing our discussion of projectile motion, so now we're going to move on to questions 5 and 6. Question 5 I'm just going to walk you through because it's the same, pretty much the same setup as the rest of them. So I'm going to get you going on it, and then I'm going to let you do the bulk of the work. So it says a supply plane needs to drop a package of food to a group of scientists in a remote area. Notice drop. Okay, we're going to talk about what that means in a minute. The plane flies 125 meters above the region. Okay, so we should recognize that as our distance in the y direction because it's how high it is, at a speed of 175 meters per second. Okay, so it's a plane flying at 175 meters per second. It's not flying down, it's not flying up, it's flying at a horizontal pace. So that is our velocity in the x direction. So our velocity in the x direction is equal to 175 meters per second. Our distance in the y direction is 125 meters. We need to figure out how far from the target should the package be dropped. So in other words, what is the distance in the x direction? So that's our burning question. What is the distance in the x direction? So just like the rest of these, if it's been dropped, okay, the package has been dropped, which means that its initial y velocity, so its initial y velocity is 0. Okay, so that means that it's in free fall. It has an initial x velocity. Okay, so its initial x velocity is 175 meters per second. So that will come into play later, because remember, our velocity in the x direction is equal to our distance in the x direction divided by the time, which means that we need to first figure out time if we are going to figure out what our distance in the x direction is. So in order to find time, we take our distance in the y direction is equal to our initial vertical velocity, which was what? 0. Okay, I'm going to plug in that. Okay. Our initial distance in the y direction is 125 meters, so we'll plug in that, plus 1/2 times acceleration due to gravity times time squared. Okay, our acceleration due to gravity is always 9.8 meters per second squared. Okay, so that will get plugged in there. Okay, so plug everything in that you know. You will eventually get t squared by itself. Take the square root of both sides. That will give you your time. Once you calculate the time, then you can plug that in here and solve for your distance in the x direction. Remember that your velocity is the 175. That will be what you plug in there. Time that you calculated from the first part of the problem will be what you plug in here. And then you'll be able to figure out what it's looking for, which is the distance in the x direction. Okay, moving on to number 6. Now we're getting a little more complicated. In a physics demonstration, a projectile is launched from the ground at a velocity of 10.6 meters per second. Okay, so at an angle of 30 degrees above the horizontal. Okay, so there's my ground. It's going at 30 degrees, not 130 degrees, 30 degrees above the horizontal, 30.0 degrees above the horizontal, okay, and 10.6 meters per second. So this is where our vectors come into play. We need to figure out what is the horizontal velocity and what is the vertical velocity. So the vertical velocity, so velocity in the y direction, okay, and then what is the velocity in the x direction. Okay, so this is where, and then we know that at that angle it was 10.6 meters per second. So that's our hypotenuse. With respect to 30 degrees, our velocity in the y direction is our opposite side. Hopefully you see where I'm going with this. Our velocity in the x direction is our adjacent side. So we know the hypotenuse. If we're looking for opposite, we need to use our sine function. If we're looking for adjacent, we need to use our cosine function, because the sine of 30 degrees is going to be equal to the opposite side, which is our Vy, divided by our hypotenuse, which is 10.6. Okay, so that's how we're going to calculate our velocities, okay, is using our sine and cosine function. Our cosine of 30 degrees is equal to the velocity in the x direction, the adjacent side, over the hypotenuse, which is 10.6. Okay? So in order to figure these out, when I rearrange them, all I'm going to do is multiply both sides by the hypotenuse. Okay? So A, what is the horizontal distance from the launch location? What is the horizontal distance from the launch location will the projectile land? What horizontal distance from the launch location will the projectile land? So what is this distance right here? Okay, so well, the velocity in the x direction is equal to distance divided by time. So what I'm going to need to do is figure out first, how long is this thing going to spend in the air? And the way that I figure that out is all based on my velocity in the y direction. Okay, so I have to set up an equation for the velocity in the y direction, and then I can work my way backwards and figure out the time. Okay. So the velocity in the y direction, we said, is going to be found using this equation. So if I rearrange that, I can just say that it's the sine of 30 degrees times the hypotenuse, which is 10.6 meters per second, okay, which is going to give me a velocity in the y direction of 5.3 meters per second once I plug everything in on my calculator. Okay, so if I then plug everything in, my time, okay, so to figure out what the time it takes, if the initial velocity, remember the final velocity at the top, so I first have to turn this into two problems. How long does it fly up in the air before it reaches a final velocity of 0? So final velocity in the y direction is going to equal 0 when it hits the top of its arc up here. So remember, it's going to fly like this, okay, and come down somewhere over here. Its final velocity up here at the top is going to be equal to 0. So that's what I'm going to plug in for my final velocity, is equal to the initial velocity in the y direction, which is the 5.3 that we just calculated, okay, plus acceleration due to gravity. Okay, so acceleration due to gravity is my 9.8 meters per second, okay, times time. Okay, and time is what we are going to be looking for. All right. So now if I plug all this in, oh, and I have to remember that because gravity is acting against it, it's actually negative 9.8 meters per second squared. So I just need to remember that when I'm going through and calculating everything. So if my final velocity is 0, okay, so that gives me, and then all right, so I'll go ahead and plug everything in. 0 equals 5.3 plus negative 9.8 times t. Okay, I'll go ahead and move that over to the other side, so I'll add 9.8 t to both sides. So I get 9.8 t is equal to 5.3. Then I just need to divide everything. So divide both sides by 9.8. Okay. So my time going up is equal to 0.54 seconds. So 0.54 seconds. The time that it takes to go up is the exact same as the time that it needs to go down. So the total time that it spends in the air total time that it spends in the air is just multiply that times 2, so we get 1.08 seconds. So that gives us the total time. Now we can plug that into our standard velocity equation. Okay, so right after we figure out what the velocity in the x direction is. So our velocity in the x direction, okay, we're going to use our cosine function. So our velocity in the x direction is equal to the cosine of 30.0 degrees times 10.6 meters per second. Okay. So that gives us a horizontal velocity of 9.18 meters per second. Okay. And then we can go ahead and plug that into this equation so that we can get our horizontal distance. Okay, so the horizontal distance is equal to the velocity times time. So if I take 9.18 meters per second and multiply that by the 1.08 seconds that it spends in the air total, that will give me my distance in the x direction, which gives me a distance of 9.92 meters. 9.92 meters. Okay, so that took care of part 1. Whew. All right, so how high does the projectile rise? Well, the height of the projectile, we're going to use our distance in the y direction is equal to the initial velocity in the y direction. So the initial velocity in the y direction we already calculated is 5.3. So the initial velocity was 5.3, okay, times time. So our time going up, because remember we only want to know how high it goes, okay, 0.54 times 0.54 plus 1/2 times our acceleration due to gravity, okay, which is working against us, so -9.8 meters per second squared, okay, times, again, the time, but only in the up direction, so 0.54, okay, and then squared because it's time squared. Okay. So we have dy equals 5.3 times 0.54 plus the quantity 1/2 times -9.8 meters per second squared times 0.54 squared. I'm going to go ahead and let you figure that out, okay, since now it's just straight computation. And then it says, with what velocity does the projectile land? So in other words, what is the final velocity? Okay, and guess what? If it launches at an angle 30 degrees with an initial velocity of 10.6 meters per second, there's no calculation that we need here. Okay, it is going to land at the same angle and the same velocity. So the initial velocity must be equal to the final velocity when we are talking about projectile motion. Okay, so the initial velocity must be equal to the final velocity, which means that our final velocity is equal to